Hi everyone, thanks for checking in. This is the photosynthesis video for the light-dependent reactions. So the first reactions in photosynthesis. What I'm going to do is draw it on my screen here. However, you can see that my page is a little narrow. So I'm going to do some erasing. You should not. Whatever you draw, don't erase, because it's going to end up looking like this. And so I want all of this on one paper. So you're going to need it kind of the horizontal way, because you're going to draw all of this. This is the entire light dependent. So please draw along with me. It's not good enough just to copy something down. You need to be able to draw it and listen as you're drawing it, so you're able to explain it when it comes to quizzes or tests or even modeling, which we will do in the future. So I'm going to get started. Before we start, we need to figure out what is our reaction. What are my products? What are my reactants in photosynthesis? Photosynthesis, we have light, we have water, and we have CO2. Those are my reactants. Hey, that's a terrible arrow. And then we have our products, which include glucose and oxygen. Glucose and oxygen. The light-dependent reactions, the reactants that we are going to use include light and water. Carbon dioxide is going to come in during the Calvin cycle. Our products of the light-dependent reactions is going to be oxygen. So we are not making glucose in the light-dependent reactions. So where does this happen? Photosynthesis happens in plants, and so let's draw our tree. There's the ground with its leaves. Yeah. And then we also have our sun up here. Okay. So we have our tree. So where does our light come in? Our light is going to come in and it's going to strike our leaves. And then where does our water come from? Our water is going to come from the ground. H2O, it's going to pick up through the roots into our leaves. So our leaves are what's doing photosynthesis. Inside of our leaves, we have cells. Every living thing is made up of cells. In those cells, we have an organelle called the chloroplast. In the chloroplast, we have stacks called granum or granum. Those stacks are made up of thylakoid membranes. Okay, so each of those circles that I'm drawing is a thylakoid. That is where our light-dependent reactions are going to take place. However, please know that the fluid stuff, so out in this area, that is the stroma. Stroma. Okay. So what we are going to draw is we're going to draw the thylakoid membrane. Our light-dependent reactants take place across the membrane. If you remember from our cells unit, membranes are phospholipid bilayers. So we have our phospholipids, and they are in two layers. They are a bilayer. So our reactions are going to take place across that membrane. So let's get started. Let's delete that. So please leave that. Don't erase any of that. Just put this right next to that big tree, because that's important to know where it happens and the reaction, or the reactants and the products. So let's start by drawing our phospholipids. So when you draw this, make sure you have some space in between your phospholipids. Okay. Because we're going to write some stuff within that. So you can just make short tails. We also have certain proteins that we're going to work with. There are going to be 4, so I'm going to draw those in. And feel free to make yours much bigger than mine. I just have a limited space to work with. This last protein, make sure you draw it like that. It's going to be important. It has a really, really special job that needs is shaped like that. It'll just make more sense if it's shaped like that. Okay, so finish drawing in your phospholipids. If at any time I'm going too fast, please feel free to pause it, stop it, catch up, and then hit play. You can also rewind this, which is really nice. You can watch it multiple times before quizzes and tests. Okay? And it's also very visual, so it's helping you to learn that way. So let's label everything here. We have our phospholipids. Okay, so we have our phospholipids. We also have proteins, and these proteins have special names. This is our photosystem 2. This is our protein pump. This is our photosystem 1. And this right here is our ATP synthase. If you remember ACE, if any word ends with ACE, most of the time it's going to be an enzyme, which in this case is very, very true. Now we need to figure out where the inside and the outside of the thylakoid is, so I'm going to put the inside on the top here. And we're going to put the stroma here. So the stroma is the liquid outside of the thylakoid in the chloroplast. Okay, it's the fluid. So what I'm going to do is I'm going to put our sun back up here. However, please know that, okay, our sun, the light reaches the chlorophyll all over the membrane. So even though I have the sun inside of the membrane, that may not make sense, but we're just going to put it there anyways. Okay, our sun is going to give light. Okay, that light is going to be captured by the photosystems. Okay, so over here, photosystem 2 as well. Now, what is that pigment that captures the light? Well, that is our chlorophyll. Our chlorophyll is within those photosystems. It's kind of all over the photosystems. Another thing we need to put into our membrane is our electron transport chain. So sometimes this can be confusing, but this whole membrane, all the proteins, that is the electron transport chain. So I'm just going to label it electron transport chain, and that's going to be all of this. Okay? Our electrons, okay, so E negative, that's an electron if you remember from physical science, is going to travel throughout the electron transport chain. And it has very important jobs along the way, which we will discuss. So energy is absorbed by the chlorophyll. Energy is going to be transferred to these electrons. The electrons are going to leave the chlorophyll and enter the electron transport chain. It is a series of proteins along the thylakoid. Where do these electrons come from? Well, we need to do something very important. We need to split our water. So our water, H2O, 2 H's, and an O. And we're going to multiply that by 2. So our water. From our water, what we are getting 4 hydrogen ions. We are getting oxygen, so that's O2, and we're getting 4 electrons. Those electrons are going to go into our photosystems, and they're going to be excited by the light. Okay? Our oxygen is going to leave the plant. It's a byproduct. It is going to leave through the stomata. So that sounds really similar to stroma, but a stomata is a hole on the leaf where gases can be passed. So that's what happens to our oxygen. So the electrons are going to enter the electron transport chain. Oxygen is released as a byproduct, and then we'll talk about what those hydrogen ions do. The hydrogen ions are going to be transported. So as the electrons move from protein to protein in the electron transport chain, that energy from the electrons is going to be used to pump hydrogen ions from the outside to the inside of the thylakoid against a concentration gradient. So let's draw this out. That's a lot of words. Let's draw this out. On the outside, we have a few hydrogen ions, okay, from that splitting of water. What they're going to do is they are going to travel from the stroma to the inside of the thylakoid. However, the inside has way more hydrogen ions. Way more. Okay, so it is moving against the concentration gradient. What kind of transport is this? Can you remember from our cells unit? This is active. Sorry, the pen is terrible, so do your best. Active transport. It is moving from a low concentration to a high concentration. Active transport. The hydrogen ions are going to build up on the inside of the cell. The electrons, okay, are going to be moving on to photosystem 1. Okay, so that is photosystem 2 and the protein pump. So now let's talk about photosystem 1 and our energy carrying molecules. Photosystem 1 is all about making NADPH. So let's talk through this. So our sun, the light is going to come in and it's going to be absorbed by the chlorophyll again. Okay. And I always do that. The electrons are going to be energized again, and it's going to be, they're going to replace those lost by the chlorophyll. So remember, electrons, they get energized and they leave. Energized and they leave. So now they're just replacing each other. So what happens is these electrons, some of them are going to leave photosystem 1. So our electrons are traveling along, and some are leaving photosystem 1. What they are doing is they are being bonded. I'm just going to erase one of those real quick. They're going to be bonded to NADP+. So plus 2 electrons. We need 2 electrons to make this molecule. What else do we need? Well, we also need some hydrogen. So some of these hydrogen are going to be added onto this. Okay? So plus H+. That is going to make our energy carrying molecule NADPH. Okay, this is energy. And this is going to go on to the Calvin cycle, which is our next video. Not wait. NADPH. So that is photosystem 1. Now we have to talk about ATP production. So this is the final part of the light-dependent reactions. Okay, it depends on this hydrogen concentration that is being built up, okay, on the inside of the thylakoid. So these guys are all over. So inside the thylakoid membrane. And this is going to occur through a very complex enzyme, ATP synthase. What it looks like is it kind of looks like a rotor. So this is going to make ATP. So what happens? The hydrogen ions are going to flow through the protein pump into the thylakoid membrane. We already talked about that. That's over here, right? Okay. And then the concentration is going to be built up on the inside of the thylakoid. The difference in hydrogen concentration is called chemoosmotic gradient. This stores up energy. So let's erase a couple of these so we can write that down. Chemoosmotic gradient. Okay. This is a very important term to be familiar with. What's going to happen is these ions are going to flow through the channel, the ATP synthase, through facilitated or passive diffusion. So those hydrogen ions are going to flow through. Okay, so this is a high concentration to a low concentration. And that is called, we'll put this in a different color, facilitated I don't have enough room. Okay, That's messy, but there's supposed to be a D on the end of that. Facilitated diffusion. Facilitated diffusion over here. Active transport was over in the pump. Now we're talking about facilitated diffusion. Through these hydrogen ions traveling through the ATP synthase, okay, this is going to create ATP. And so what it's doing is it's taking a free ADP molecule, it's adding on a phosphorus, and it is making ATP. So the energy from the chemoosmotic gradient, okay, traveling through the ATP synthase, it allows the energy to create ATP. So another energy carrying molecule. These two molecules, NADPH and ATP, are then going to go on to the Calvin cycle, and that's what the next video is. So hopefully you learned something. I'm sorry about the mess, but I'm sure your paper is a mess as well. So thanks for watching, and I'll see you in the next video.